chapter number 5. Topic of today's lecture is 5.1. Pages covered 107, 108, and 109 and 110 pages we will cover today. So I start my lecture. This is the chapter unit number 5. Here, the name of the unit number 5 is gravitation. In this unit, we will study about the gravity, force of gravity. And before starting this, I will give you a brief introduction about what we did last time in audio. The last time my lecture was in audio, so I can't share my screen last time, but this time I come up with my screen share. I'm doing the same lecture again. The first man who came up with the idea of gravity was Isaac Newton. It was an evening of 1665 when he was trying to solve the mystery why planets revolve around the sun. Suddenly, an apple fell from the tree under which he was sitting. The idea of gravity flashed. The idea of gravity flashed into his mind. He discovered not only the cause of falling apple, but the also the cause the cause that makes the planet to revolve around the sun and the moon around the earth. This unit deals with the concept revealed to the gravitation. This is the small background before he discovered before Isaac Newton discovered gave the concept of law of gravitation. This was the brief history. What he was doing, he was trying to solve the mystery of gravitation, and there are so many questions arose in his mind that why the planets are revolving around the sun, why the moon is revolving, why the earth is revolving around the sun. So suddenly an apple fell down from the tree, and this falling down of apple gave him the idea how the things are moving, how the planets are revolving around the sun. So in this unit, I am going to start 5.1, the force of gravitation. The force of gravitation, I told you last time in my audio lecture, what is force of gravitation. But I repeat, on the basis of his observation, what he did in this paragraph, uh, on the basis of his observation, Newton concluded that the force which causes an apple to fall on the earth and the force which keeps the moon in its orbit are of the same nature. So when the apple fall down from the tree, an idea flashed into his mind why the planets are revolving around the sun. So he said, what is the force which causes the apple to fall down? The same force is existing between the planets to revolve around the sun. He further concluded that there exists a force due to which every body of the universe attracts every other body. He named the force the force of gravitation. If you open your ninth class book 105, 107 page, you will find this definition. So I read the definition, the statement of the law of gravitation, or law of gravitation according to the Newton's law of universal gravitation. Everybody everybody in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So this is the statement of the law of gravitation. Every body in the universe attracts every other body. Suppose these are two bodies. One is of sphere, one sphere is of mass m1, and the other sphere is of this is blue, and this is suppose this is pink or this is red. So this is m1 body, and this is m2 body. So he is saying every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So if I consider M1 is attracting M2, similarly M2 is also attracting M1. So when M1 is attracting M2, he is applying the force F with the force of traction. This is the force of traction. This is in this direction. But when M2 is attracting M1, so there is another force whose magnitude is same as that. The force acting from M1 to M2 is same as when the M2 is attracting M1. So their magnitude is same, but their direction is different. So minus sign is indicating this. This is opposite is that of this force. But these forces are equal in magnitude. What does this mean, magnitude? Magnitude means if this is 10 Newton force, this force will be also 10 Newton. But if their direction is this side, right hand side, this direction will be on the left hand side. So these forces are equal in magnitude, or this body is attracting this body with a force F, but this body is attracting M2 is attracting M1 with a force F, but these forces are in opposite direction. What he is saying in the law of gravitation, the force of traction is directly proportional to the product of their masses. So M1 is the mass of this body and M2 is the mass of this body. The product of their masses and inversely proportional to the square of the distance. So where will you take the distance from this center of this body to the center of the other body? This will be the small distance. But when he calculated all this formula, or he applied this formula, or he calculated this formula, he concluded that force is directly proportional to the product of their masses, because there is a multiplication sign between M1 and M2. We say this is the product of their masses and inversely proportional to the square of the distance between them. So if I move towards the other side, so what he says, I'm going to that force is directly proportional to M1, product of M1 and M2. According to the law of gravitation, the gravitational force of traction F with which the two masses M1 and M2 are separated by a distance d attract each other is given by force is directly proportional to the product of their masses, because there is a multiplication between M1 and M2. So product of their masses and force is also inversely, because D is in the bottom. So we will say force is inversely proportional to the square of the distance. So if we combine this and this, the force will be written once, and M product of their masses will become on the top, and distance will become at the bottom. So force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Students, you know this, when we remove the directly proportional sign, so what will happen? We get equal sign and some constant of proportionality. In this case, constant of proportionality is capital G. So equal sign and capital G. When we remove this directly proportional sign, we will get equal sign and some constant of proportionality, and that was the constant of proportionality is called gravitational constant, and it is denoted with the capital G. Its value is SI unit. Its value is where G is the proportionality constant, or we can say constant of proportionality. It is called universal constant of gravitation. Its value is same everywhere. Wherever you go, its value will be same. In SI units, its SI unit in SI unit, its value is 6.673 into 10 raised to the power minus 11. And you know the unit of G. Unit of G will be unit of G will be 6.673 into 10 to the power minus 11 Newton meter square per kilogram square. This is very small value. Why this is, I am saying this very small value? Because 10 raised to the power minus 11 is the negative number. Is the negative number. Is the negative number. So this value is very small. 10 raised to the power minus 11, because we will place the 11 zero on the left hand side of this side. So if this value is very very small, so due to the small value of g, the gravitational force of attraction between objects around us is very small, and we do not feel it, because this value is very very small, because it is raised to 10 raised to the power minus 11, and the power of 10 is negative number minus 11. So it is very very small, and 11 zero will be placed on the left hand side of 6.673. So this is very very small value, so between the objects, so we don't feel it. Since the mass of the earth is very large, if you see, as compared to the body, the mass of the body is very small. If you figure 5.2, the mass of the body with which the earth is attracting this body, the mass of earth is very very large, but mass of the body is very very small as compared to mass of the earth. So mass of the earth, we will take it me, and mass of body is taken as small m. So mass is Earth is attracting this body, and similarly with the force F, and similarly this body is also attracting Earth with the force this. But these forces are equal in magnitude, and they are opposite in direction, because this direction is upward and this direction is downward. This is law of gravitation, and r is the distance in this center of this body to the center of the Earth, is the distance between is denoted with small r. So you should know mass of Earth is denoted me. Me means wherever m will be capital, because it's the Earth of mass of the Earth. That's why I am taking m as capital, and E stands for mass of Earth, and small m is the mass of the object, and r is the distance between center of the mass, center of the body, mass of the body to the center of the mass of the earth. So r is the distance between their centers. So law of gravitation of sometime law of gravitation is also called Newton's third law of motion. Why I am saying law of gravitation is a Newton's third law of motion? Because the law of gravitation says one body is attracting other body with a force which is directly proportional to the product of their forces, masses, and inversely proportional to the scale of the distance. Because when m1 is attracting, as we did in last, m1 is attracting m1 is attracting m2 with the force F, and m2 is attracting m1 with the force F, and their negative sign shows that its direction is different. So in Newton's third law of motion, if you read the statement of the Newton's third law of motion, it says that every action there is a reaction. They are equal in magnitude but opposite in direction. Similarly, same thing is happening in the law of gravitation. This body is attracting this body with the force F, and this body is attracting this body m1. M2 is attracting m1, so with the force F. So they are equal in magnitude but opposite in direction. This negative sign indicates this is the opposite in this force is in opposite direction. That's why I'm saying law of gravitation is also called Newton's third law of motion. Now we solve the example 5.1. I read the numerical statement for you first. Two lead spheres, each of mass 1000 kilograms, are kept with their centers 1 meter apart. Find the gravitational force with which they attract each other. This is the example 5.1 on page number 108. I move towards next. This is 109 page number 9 of M1 is 1000 kilogram, and M2 is 1000 kilogram as well, because two lead sphere equal masses. M1 is 1000 kilogram and M2 is also 1000 kilogram, and distance between these two masses is 1 meter. So I will use the same formula, which is called the law of gravitation. F is equal to capital G m1 m2 divided by d square. I'm just putting the values. You know the value of a capital G of law of gravitation, universal law of universal gravitation. Its value is 6.673 into uh, into 10 raised to the power minus 11 Newton meter square per kilogram square. I am putting the value G. You can see if I go back, the value of G is found to be 6.673 into 10 raised to the power minus 11 Newton meter square per kilogram square. So this value is capital G value, and this is very very small value. Now I am substituting this value into my formula. In my formula, F is equal to G m1 m2 divided by d square. So I'm going to put the value G is equal to 6.673 into 10 raised to the power minus 11. So m1 is 1000, then m2 is again 1000. So distance is 1 meter. So I'm going to put this one. So if you multiply and solve, sorry, if you multiply and solve 1000 multiplied by 1000, 1, 2, 3, 1, 2, 3, 6, 0, 10 raised to the power 6. So minus 11 plus 6, it is 10 raised to the power minus 5. So the force of attraction between these two masses, M1 and M2, will be 6.673 into 10 raised to the power minus 5 Newton. So I have solved this numerical. So now I'm moving towards gravitational field. Now I'm moving towards gravitational field. The concept of gravitational field. If I go back and I show you the figure where this equation is coming from, I showed you the figure now because we discussed the figure. Look at the figure. I told you m is the mass of the earth and m is the mass of the body. The distance between these two masses is from their center is denoted with small r. So you should keep in mind this figure when we take the concept of gravitational field. The, open this page in front of you when we do the concept of gravitational field. So m1 me mass of earth, this mass, the earth is attracting this body and this body is also attracting earth. So a force when the earth is applying the force on m, the force will be in this direction. When the small body as compared to the earth is applying the force of traction will be in this direction. So they are equal in magnitude but opposite in direction. Then our law of gravitation, this law will become as. Our law will become as F is equal to G m m e r square. In the last example, when we discussed two bodies, m1 and m2, their masses are very small. But in this case, since we are using two bodies, we are taking two bodies, Earth, and we are taking two bodies, Earth and the small body. So mass of Earth is will be taken as me, and the other body is m. You should keep in mind the figure 5.2 because I drive this law of gravitation on the basis of equation figure 5.2. So F equals to G m m e over r square, where m is the mass of the earth and r is the distance of the body from the center of the earth. So where me, he has told us, where me is the mass of the earth and r is the distance of the body from the center of the earth, as I showed you the figure 5.2. So the weight of the, the weight of the body. What is the weight? Weight is the force with which the earth attracts the body towards its center. You know the definition of weight. So weight is the force with which the earth attracts the body towards its center. So weight of the body is due to the gravitational force with which the earth attracts the body. As I have already told you the definition of the weight. This is the definition of the weight straight away. Gravitational force is a non-contact force. Non-contact force means there is no contact. There is no physical contact, but it is a non-contact force. As you take the example of magnet, the magnet attracts the other magnet, because it try to pull it towards itself. So it is there is a field coming out of the magnet. So similarly, this is the non-contact. If we are in contact or if we are not in contact, the gravitational force is this force is a non-contact force where there is no contact. For example, the velocity of a body thrown up goes on decreasing, while on return its velocity goes on increasing. What is this? If you throw the ball upward, what will happen? The velocity as the ball will go up, the velocity will decrease, and when the velocity will be zero, the ball will come back. When it is coming back, its velocity will increase. When it is going up, when the ball is going up, its velocity is decreasing. When the velocity is zero, then the ball will come back to the earth. So when it is going up, its velocity is decreasing, and when it is going down, its velocity is increasing. You can see the example of a ball. This is due to the gravitational pull of the earth acting on the body, whether the body is in contact with the earth or not. The ball is not in the contact of the earth, but there is a force which is acting on the ball and taking it towards the earth, towards that. But when we throw the ball upward, it is not coming, it's not going up. It will come back to the earth. You know why? Because there is a pull of the earth which is attracting it towards its center. So similarly, as I gave you the example of the magnet, there is the forces are coming out. There is a magnetic field is coming out. But the force also has there is a field exists between there is a field exists uh, between the earth. If you look at the earth, there is a field. The arrow line shows this is the field of the earth. So it is assumed that their force is called the field force. It is assumed that the gravitational field exists all around us. This is the field. This is the field which exists all around the earth. All around it is assumed that the gravitational field exists all around the earth. The field is directed towards the center of the earth as shown by the arrow. The field is directed towards the earth because the arrow is pointing inward. So when they are pointing inward, it means it is existing towards the center of the earth. The gravitational field becomes weaker and weaker as we go further and further away from the earth. As I gave you the example of the ball, when we throw the ball up, it means when we going up and up, the gravitational field going weaker and weaker. But when we come back, so its gravitational field becomes stronger. So in this paragraph, you need to memorize this formula, and you need to memorize the field force, the definition of the field force, and the other example I will show you in a short. In the gravitational field of the Earth, the gravitational force per unit mass is called the gravitational field strength of the Earth. This is the definition you got to memorize. This gravitational field. One definition is gravitational field, and the other is gravitational field strength. And the unit of gravitational field strength is 10 Newton per kilogram. So this is the unit of the gravitational field strength. So student, you need to memorize two things. You need to memorize two things: the definition of the field force, which is this is due to the gravitational pull of the earth acting on the body, whether the body is in contact with the earth or not. Such a force is called the field force. This is the force. This is the definition of the field force. So you need to memorize this definition, field force, and the other things you need to understand. This definition you need to memorize this. Everybody in the universe. This is the law of gravitation. In the examination, they will say you what is law of gravitation. Then you will memorize this definition. Every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So, and you need to memorize this formula. F is equal to G m1 m2 divided by d square. This F is equal to G m1 m2 divided by d square. You need to memorize this formula. So this definition and this is the formula you need to memorize. So when they give you what is defined law of gravitation, then you need to define this definition, then write this formula and also draw the figure. Other thing you should also know, they also sometimes give you the long question. They ask you what is law of gravitation. They also tell you how law of gravitation and Newton's third law of motion relate to each other. So you have to start from here, and then you have to write it till here. So this will be the 4 marks question complete from definition of the law of gravitation to, and then this is the proof of how this equation comes from, and then law of gravitation are related with the Newton third law of motion. But what you have to uh, gravitational field. I told you what is gravitation. You need to memorize this one. And what is ME, what is M, what is the R, you need to know. And there's and gravitational field and field force, definition of gravitational field, the field force, and one more thing, gravitational field strength. Students, I hope you all understand this topic very well. So this is the end of the today's